In this video, we're going to learn how to build classes in Java. And let's just get a new project going. I'll call it My First Class. And so far, we really haven't taken advantage of the reason that Java was built and the way that it's meant to be used, because we've been trying to give you the basic building blocks just to kind of, get some grammar and be able to speak a bit of Java. But at the heart of Java is object-oriented programming, meaning everything here is built into an object. And to do that, we build classes. So Java is a language where everything has to be built in a class. And you might have seen this here. This is a class called main, and within main is our method that we've been doing all our programming in. So now I'm going to show you how we can make our program use classes that we build rather than everybody else's. And the idea here is going to be that we're getting programs so big that all this code shows up in main, and it's very hard to track down errors, and it gets hard to read because it's so long and it almost seems disorganized because it's just not a convenient way to structure things. So instead, I'm going to show you how we could build it with a class instead. So today what I'm going to do is I've got this little project idea that I'm going to work you through. Oops, not the right slide. There we go. So I'm going to build a point class with you, and with this point we're going to code it in Java. So this is sort of my idea of what we're going to model. A point is just a two-dimensional one with an x and y coordinate, and some basic things that the point class should be able to do. I'm also going to do another one where I get the distance. Let's just say get the distance between another point. Distance to another point. But basically we're talking about the behavior here. So in terms of requirements for what we want to be able to do, a point has certain things and a point does certain things. So in Java we call these fields, and these are variables that belong to the point. When things that a point does, the actions and behavior of it, we call those methods. You might have also heard the word function used around, like a member function. That's some of the terminology that you might hear other people use as well. And here you might hear member variable. But anyways, in Java, these are called fields, and these are called methods. So first thing we want to do then is create a new class for this. And we go to New Java Class. So I'll make it a point class. And it's just like your main program that you've already been doing. If you do need to make any imports, you can bring them in here. But this is a simple class just to give you the idea. We're not going to need any. So the first thing, like I said, is a point has an x and y coordinate. So the way I show that in Java is I declare the variables. So I'll say int x and int y. Now, this isn't quite the way you want to declare your variables. There's this extra bit of information here we haven't really talked too much about, and that's access. The access here is public. Java has several ways of doing access. We're going to just focus on public and private. But public access means anyone can use it. So if you make a public class, anybody can use that code in their library as well. And I don't mean that they just can like link and hack into your computer, but what I mean is if you share that library, you're making it available to them. Now some things you want to hide from the people who are using your library, because you might feel like, well, if they were to have direct access, they might be able to mess up my class. Maybe they would wreck the internal consistency or some expectations that you have, some preconditions about it. But basically, it's a part of your class that you don't want anyone to mess with. And generally, that's what these member variables or fields are, is things that we want to hide. So to hide them, we just tell Java that they're private. So we say private int x and private int y. It's not as though we're taking it away completely. I'll show you very quickly how we can still allow some access, but we can control completely the way that someone accesses those variables. So what I have here, just to recap, is I'm creating a new set of objects called the point class. Each point will have an x and y coordinate. Actually, I suppose a double is probably a more appropriate data type for points, so we'll make them doubles. Okay. So now that I have things for the point class, I should be able to build a point. And the way we build it is with a constructor. So a constructor looks like this. And the way Java recognizes that it's actually a constructor is it has the same name as the class itself. So again, I have to say to Java, anyone can call on this constructor. So I'm going to call it public. And Java recognizes that it's a constructor because it's the same name as the class. So in here, what I want to do is, this is where I initialize my objects, or I set everything up so someone can start using them. So here, if I just create an empty point, then that means nobody's told me where the location is. So why don't we assume that I'm going to the origin? And so I'll probably make a comment here like origin is the default point. Okay, so if I create a point and I don't give any values, it'll send me to 0, 0. Now before we go any further, one thing you might not have noticed is, maybe it's hard to see on the screen, but I've put an underscore after each of the variables. And that's one of the conventions that I like using. Some people do this instead. They go like they put an M underscore in front, like my X and my Y. And this is really just a way of helping the programmer know that I'm talking about a special variable here. This is the variable that belongs to the point itself. These are the ones which are the fields, not just a regular variable. Because I'm still able to do things like go double new x equals 5, and then can continue to do some work with those variables. But I know by reading my code that, oh, because I'm putting an underscore after it, this is actually the fields of my class, not just any old variable. Okay, so that's not very useful then if all I do is create a point that has 0, 0 is the only way I can do it. So we might decide, well, we'd like to make a constructor in several different ways. Maybe I'd want to also go and build a constructor where you give me an x and a y. So in here, this is my field, remember, this is the one that belongs to the point. So I'm saying take this object's x and make it equal to the x that they gave me. Take this object's y and make it equal to the y that they gave me. So now I have a constructor that can take in the coordinates as well. So if I create a point, it'll give me x and y, and I'm able to use those now and assign them to the private member variables. So what we've gone so far is we've said a point has an x and y coordinate, and this is how you build a point. So now we're going to start making some methods for our point class here that we can start using. So things like the behavior, which is what I'd mentioned here. So we want to be able to get those coordinates. We want to be able to change them, move them, print the point, and get the distance to another point. So let's try this here. If I want to be able to get the coordinates, then this is how you declare a method. Remember the difference between a method and a constructor? There's a couple, but first of all, the constructor has to take on the same name as the class like this. Now, a method is going to return, well, it doesn't have to return something, but we have to give a return type to Java. So here, I'm going to say public double get x, and this is going to be my method that returns the x coordinate of this point. So return x. That way, if someone's using my point class and they want to know what is the x coordinate, here's how they get access to it. Now, there's not much difference between this and actually just letting this be public, but again, the practice is, and there's a lot of reasons when you make more complicated classes, that you don't want to give direct access, that you only want to be able to show certain parts of it. So this is how they still get access to know what x and y are, even though it's private. Okay, so I'm going to do the same thing for getting a y coordinate, and then we'll talk about what these methods look like. So again, you always got to start with the access. How can people use this object? This is public, so anyone can do it. Then I have to tell Java what's coming back, because you do things like in here where you go, say, string s equals hello, and then I say index is s dot index of h. Java needs to know what's coming back from this method index of in order to know what kind of memory to set aside and what kind of object to assign it to. So this is me telling Java the result when this thing is finished is a double. And anyone can refer to it by this signature, get x, and they don't need to give any parameters. All I'm doing is returning it. So the method starts in this block, right in this brace, and ends here. And all I'm doing is, this is how I give something back, is I use this command called return. So I return the x value, and that is a double, so Java, everything checks out, there's no syntax errors. If I didn't have that there, Java gives me this little error because missing a return statement, it's expecting a double. You know, I can't even, like, if I return a string, I still get an error because they're incompatible. You can't return a string if you're just saying it's a double. Okay, so now I have the ways to access the x and y coordinates of the point. The other thing we said here was we wanted to be able to change those. So I'm going to create some methods to do that. And I'll tell you a little bit about what I'm doing as I get it down. But this is the basic template that I'm going to use. And again, my access type is public, so anyone can change the coordinate for the x. But the return type is called void, and what void means is there is nothing to return. This is just a method that performs some action for us. Because I'm not actually returning the value, I'm just setting it. They give me this value of x, and I assign it to my field. So in here, this is the value that my object holds on to. It's the one here, x underscore. You notice NetBeans is conveniently highlighting it in a different color, which is green, whereas the other variables are black. But basically what I'm saying is, you give me a double, and I will take that number and I will assign it to the variable I have for my point class. So I'll do the same thing for the y coordinate, public void set y, and I need a y coordinate here. And now I'm able to update whatever the y coordinate was in my point. Okay, I'd also like to be able to move the point. So let's make a method for that, public void move, and some change in x, some change in y. So if this is what I'm doing, I'm just going to add this amount of change so that I update the private member variables. So x plus equals dx, just add the change to it. I'll do the same thing with y. Now typically we also call these, we have some special terms for them, and typically what we call these accessors, things which access data or fields within our object, and we call these mutators, things which change the state of our object. So all of these update the private member variable in some way, so they mutate or change that object. So you might hear that term used as well. Now, I also have the task of printing the point. And Java has a very specific way that it likes to do this, and it's the toString method. And I'll show you why that is when we get to our main program here. But you could call it anything you want. This is just one that Java knows very well, and I'll explain it once it's done here. So what I want to do is return how I'm going to represent the point, and basically for us that just means I'm going to do this. It's just going to return it, oops, forgot a plus sign here. It's just going to return the x and y coordinates between some braces, sort of like the way we represent a point in mathematics. And then the last thing I have here is get the distance to another point. So public double distance, I'll call it distance 2, and I'll give it another point. So the way we can do this is we want to get use Pythagoras theorem for it. So the change in x is going to be this x minus the other point's x. Now you notice I've got direct access here. There's two ways I can get that coordinate. I could just go p dot and click on the get x. That's fine. That'll work for us. But it is a little quicker if I just ask for direct access. You can't do this anywhere but within the class file. And that's really what private means, is private can only be done and accessed directly if you're inside this block of code here, if you're inside that class. So this direct access I can do because I'm inside the point class. And basically we're saying we would assume that that's a legitimate way for you to have the access because you're not just any Joe Blow using the code, you're within the code itself when you're making this change. And again, I said there's nothing wrong with doing it this way where we just say go to the point and get its x, but basically there's some overhead involved in a function call, so this code will run faster if I use direct access. So, as far as what my expectations are for us in the course, don't worry about either way is perfectly acceptable. You wouldn't lose marks like that, but I'm just showing you that it is possible to do direct access because I'm within the class, and it is a little faster. So I'll stick with that. You might not have also caught it there, but I'll also show you, you can see this little lock here, that's showing it's private, and then this, there's no locks here, these are all the public methods. So I know that this blue box basically is denoting a field. So I know that this is one of the member variables, whereas the red dot is denoting the methods, and the lock on it means it's a private field, and this would be a public method. So we're just going to grab it, take the difference. So the Pythagoras theorem, return math dot square root of dx times dx, so dx squared and dy squared. Okay, so this is the formula for the distance between 2 points. Again, if you like, you could also choose to go math.pow dx squared. That's fine too. Nothing wrong with that. I'll keep it here. A little simpler, and it is a little faster because there's no overhead of the extra function call. So this will calculate the distance between 2 points for me. Now at this point we're done our class, and I want to show you a few things that we've done. It's very simple in its behavior, but that's fine. We can specialize it and use it for things that are complicated. But as far as my thought process went, look at how small all the blocks of code are that I had to write. All I'm thinking about is confined to this one task. So get x, I mean, there's only one thing to do. That's why I'm only returning the one statement. Moving it, I just have to remember to update both of the coordinates. So when I'm programming, I'm not thinking about the entire program at once. All I'm thinking about is what do I do in this one method? And then similarly here, the toString method, how do I return the data in a pleasing way? Well, again, that's one thing to focus on. It's very nice to work this way. It also means that if I called the toString method and it didn't look right, I would know exactly where I need to go in my code to fix it. So, for example, if it printed with a semicolon, I wouldn't want that to happen. So I would know, there's an error in this method right here, and that's all I have to go and examine in my code. So again, that's another huge advantage when we're trying to program complicated things. And same thing if the distance wasn't operating properly. This is the only part I need to go to. So there's a lot of advantages there, and I'm going to show you now how we actually can use this in a main method. So we're going to create a point, and I'll call this origin, and then I'll print it. So if I run my code, this creates the object, and this prints it, and here's my coordinates, 0, 0. So anyway I want to use this point now, look at how simple the code is in main now for all the things I would be doing. I'm just calling on the methods where I need to use them. This toString method I picked on purpose because Java knows about this one, and for classes that implement toString, then I don't even need to ask for it. If Java can't find it, it'll just look and say, oh, they do have a toString method. It knows how to change your object into a string. So that's kind of convenient because in places where Java wants to convert your object to a string, you've just given it a way of doing it. Okay, so we'll take a couple other ones here. Let's do point. We'll call this top right, and I'll put this point at 2, 3. So it's not really top right, but it's in the quadrant number 1, so the top right relative to the origin. And we can take another look at it if you want to see what it would print. But we can try some more interesting things here. Like, for example, I can go, let's find out how far it is from the origin. Let's find the distance to the top right. So there, it's done all the math for me, and again, all I'm doing is calling on the methods in main. I don't really need to do a lot of code in here. Everything can be nice and compact. We can also do things like implement the Compareto interface, which is another method that Java likes to know about. So down here, if I wanted to return the Compareto method, maybe I'll put it underneath this. I can compare this point to another one, which I'm calling P. So one way I could do that is I could take a look at the distance and see who's farthest from the origin and make that the biggest point. So basically it would be sort of like if that point was on the radius of a circle, which circle would be bigger. So here's how we could do it. So I'll create the origin, and then I'll go double d1 is equal to distance 2, and sorry, that's the origin, distance 2, and I want to get the distance from the origin to the point I'm working with, which you kind of wonder, well, how on earth do I access the thing I'm building? Like, how do you talk about points when we're still building them? And Java has an easy solution for this. It knows this keyword, and it's this keyword, which, yeah, that's confusing, but this keyword is Java's way of finding the object you're currently working on. So you can use it anywhere in your code. For example, up here I could have said this x coordinate, and it would work exactly the same. If you don't put it there, Java does it implicitly for you. So you don't have to state it in these cases, but you can't just leave this blank or Java thinks you haven't given it anything to work with. So by putting it in here, now Java knows, oh, what's the distance from this to the origin? It would be the same thing as if we went this to the origin. And I'll go double d2 is equal to the distance from that point to the origin. So whoever's farthest is going to end up getting being largest. So I'll say if d1 is greater than d2, then here I can just return a positive number. So I'll return 1. Otherwise, if d1 is less than d2, it's not as far, so I'll return a negative number. It's smaller. Otherwise, they are the same, so I'll return 0. So here I've been able to look at the 2 points and decide which one's farthest from the origin and return which one is bigger. Again, one task that my brain has to think about, one thing I have to program. So in main here, if I wanted to compare them, let's just say I'm going to take, let's get rid of this, and I'll say my test point, let's put it at 5, 7. So this one is much farther away from the origin than this one here is. So if I wanted to system.out.println test.compare to the top right, then I should get a positive number here. Yeah, positive 1 because it's bigger. Now, if I reverse them, just to remind you about the way Compareto works, it should be negative because top right is smaller than test if they're being compared. Okay, and if they're equal, like test as it compares to test, it's 0. So you probably want to test your code a little better, but if I do something like this, I've moved the point, but in terms of its distance, it's the same. So if you were to graph these points, you'd see they're the same distance from the origin. So when I compare them now, my method's working the way I expect because I got 0, meaning that they are the same magnitude. So these 2 points are equivalent even though they're different values. So you can define the behavior here if you needed to change it or make it different for your program. But this is what you should be comfortable with doing now, and that's creating a class, declaring its member variables, its fields, and then creating a constructors and the methods that define its behavior. So from now on, what I'm going to be looking at when you turn in your programs is that these methods that you create help keep your code manageable and within about 20 lines of code. There are some cases when you can't really help getting over 20 lines of code, but for the most part, if you have, say, 100 lines of code in your method, it probably means there's more than one thing happening in that method and that you should break it into a few smaller sub-methods. Okay, so before I let you go and do your own class, there are a couple things I just wanted to show you here. Now, the first thing is called overloading, and this is overloading here. That's when I have 2 functions with the same name, and in this case it's 2 constructors. 2 constructors, so Java's overloading them for me. And the way Java knows that they're different is by what we call a signature. So the signature is made up of its name and its parameters. So even though these names are the same, the parameters are different, so Java can tell them apart. There's nothing to stop me from making a method like this where I go public void set x, and maybe this time I'm going to put in a string s, and in here I'll define, you give me a string version. I don't really know exactly how. Maybe we convert it to a double first and then assign it, but Java's not complaining here because same name, but the parameters are different, so everything's fine. We could also do it. This is a problem. I mean, it's not enough just to change the letter because all Java's looking at is a double. What we could do is, add another parameter. So now I have 2 parameters here, and Java knows that, well, 2 is different from 1. It would even be different, if I had this, because one's a double and an int, the other is a double and a string. So the signature is what allows us to overload a method, meaning we're using the same name, but we're distinguishing it by its parameters. So you can do that if it makes sense to you and give many different methods. Probably one of the best ones that you might have seen is like the system.out.print. Like, look at all the print commands in here, look at all the print line commands. The difference is they're different types here, and then there's no parameter here. So different parameters in here. Now, the other thing that we need to talk about is proper documentation. This class is fine for me because I'm the one who built it and I would be able to use it, but it's not exactly a good design. And the problem is I would have to explain this to the next programmer who's going to use it because I really haven't put much comments into it to explain what I'm doing. So that's what I want to show you now is the standard way that Java does commenting. Now you might have noticed, we've been looking at a lot of documentation. You might have noticed that it's very standard. Like if I go Java string, then I get this page that comes up with all the Java string documentation, and it looks very similar in terms of formatting and the style. And that's on purpose because then as a programmer you get used to seeing how the documentation's written. It would be kind of it would take you an extra effort to figure out what was going on if every time you look for the documentation it was in a different format. So it's on purpose that way, and it's built into the way that the Java compiler can take your comments and make it into javadoc. So let me just direct you here. This is the tutorial how to write comments for javadoc, and I'll link it for you. But basically, you're looking for Oracle because they're the ones who own Java currently. But basically, there's a long document specification here on how to do it. It'd be just good if you went here and took a look at the examples that they provide. So that's what we're going to do, and I'll show you the way that the method works. And the first thing you need to do is, it's not just /*/ anymore. You actually want to add an extra star there on purpose. So 2 stars means you're beginning, it's not just an ordinary comment. Now I'm saying this is Java documentation. And you'll see up here there's Java documentation actually already started. So if I wanted to explain what this class is, that's where I would put my comments. So I could put here, this is the point class, which is meant to represent a two-dimensional coordinate in Java. For example, point P equals new point 2, 3 represents the point on a Cartesian plane with x equal 2, y equal 3. So, it's a pretty simple class. If you had other things that you wanted to put in your comments, this is where you could describe the class itself. And these little, when you use this @ sign, that's a special thing that javadoc knows for organizing what you've got. So this is, for me, is just keeping track of the author. There's other things you can put in here. Again, if you want to see all the things that are available, then you want to refer to the specifications. But for us, that part's not really that important. You don't need to keep it there. But what is important is that we describe each of these methods as well as their parameters. So here's what we would do is we can describe them here. So this is the, you know what, we don't even need to say, we can say the default constructor for the point class, where the values of x and y are initialized to the origin. Maybe I'll move this down just so it prints nicer. X equals 0, y equals 0. So now somebody that comes across this is going to know how to use it. And if I go here, sorry, let me just, we'll pick a point instead. Let me pick one with a parameter. I just want to show you how Java starts to update this for us. You see now it even knew to jump in and throw that parameter down as well. So that parameter tag is, this is Java's way of saying, hey, I see you have a parameter called x, tell me about it. So let's describe this one. This is method to update the x coordinate of the point. So parameter x, and I'll just put a little description of what it is. The new value of x to set this point. Okay. Now I'll run this and watch what happens. Nothing's going to happen differently to the code here. But watch what happens now when I go top right, dot, and I gave some code here, and there it is. So now Java's actually taking my efforts and it's making comments so that a programmer now can say, oh, okay, this is what setX method does. It updates the x coordinate of the point. X is the new value to set this point. So now I don't have to go digging into all of your code and trying to figure out what it does. I can actually read it from here. Now the other thing that we can do, let me just, I'll save this, is up here when we want to build it, I can generate the javadoc for it. So it's not going to be very interesting right now because I've only put a few things in it, but when I click on generate javadoc and then it tells me where to find it, and now it's showing me, here's what it did for me, and there's that standard Java look that you have. If you don't want the frames, then obviously just there. Now it's probably more like what you've seen. I have a main class and I have a point class in my project, so here's what I've defined. And you notice that this has some code here, some comments. Here's my comments about the class itself, and here's my methods that I can do. So as I start filling it in, Java's going to update for me. This is the method to update the x coordinate of the point. If I click on it, again, there's all that code nicely formatted for me. And here's how it knows where the parameters are, because it said in my code that I've got a parameter. So I can have more than one parameter, like in this move method. And again, if I go like that, Java's done it for me, which is kind of handy. So dx is the amount to change the x coordinate. And this is the amount to change the y coordinate. this method moves the point by a given amount for both x and y. And then maybe I want to provide an example. Point P is a new point. P dot move 3, 5. And then maybe I'll say here P system. Actually, I'll just say now P is at the position 1 plus 3, 1 plus 5, or 4, 6. So that way, if someone reads the code, they have a better idea of what's happening, and that's all you really want to know as the programmer. I don't really want to have to know how is it that you coded that. I just want to be able to use it. So there's a lot of things in life that you think about. If you actually had to understand everything about how you would build it in order to use it, that we wouldn't get very far. I mean, think about every time you make a telephone call. You're not really interested in all what's happening underneath the scenes, but basically you want to know that as long as I dial the number, it'll connect me to the call, and my voice will show up on the other person's side, and their voice shows up on mine. So it's similar here. I don't want to know how you did it, because that's your job. You do it in here, and I'll believe you when you tell me the stuff here about your method. But now if I go and I take a look at my javadoc, so the test point, it was the move method we just did. Now the parameters, there's 2 of them there showing up under the parameter list. So my expectations for when you build a class is that you do your Java documentation for what your submitted work is. Now you'll notice I'm not going to spend a lot of time, because I don't want to waste your time, doing javadoc in the rest of the videos, because that just takes extra time, and if you know how to do it, it's there. And as you're programming and working on your methods, you can be building this code. It's your final project, the one you're presenting for marking. That's where I want to see the Java documentation comments made. So you at minimum have to have all your methods commented, as well as some sort of indication of what your class is for, just like we did here. Then the tags that you need to use are the param, for any method that has a parameter, and you're going to notice there's one more tag that I would like you to use, and that's the return parameter here. So it only asks for that if it's not a void. The reason it didn't give us one before is it's void. We don't return anything. But anywhere that there is a return statement, then it will also do it here. So now it knows I'm giving something back. So here I can say gets the x coordinate of this point, return x value of this point. Okay, and again, sometimes it's not so obvious, right? Like the distance here. Here's one where I've got parameters and a return type. This calculates the distance from this point to another. And the parameter here is p. This is the point to find the distance to, and it returns the distance between this point and the point given, which is p. So again, all that JavaDoc's there for me. Now when I ask for the distance, there it is, calculates the distance between the points. Here's my parameters, here's what it returns. So if I wanted to push this out and publish my work somewhere where other people could use my library, you go up to run, generate my Java documentation, it'll update and save everything for me. And now all that stuff I've added to it is going to be here in the point class. So for example, down here, there's the move method that we put in. And you might be looking at it thinking, oh, it didn't really do a good job because look, it's all on one line. And so the last thing I'll say about JavaDoc is if you know a little bit of HTML, then you can add HTML tags to your code in order to help out its readability. So I'll just show you one way to make these is the break command, which is just if I go like this, that's the HTML to force your browser to display it on another line. So if I was now to, sorry, I need a new line here. If I was now to go and take a look at my JavaDoc, See, now it's all on different lines. So if it's important the way the formatting is supposed to look, then that means you need to do a little bit of digging into HTML tags and add those to your code. So that's basically what it's going to tell you a little bit more about in the documentation. Okay, so now when you build your class, you are of course responsible for handing in the completed version with your proper Java documentation.